Hello everyone, it's Ryan back here on the Syntax Byte. In this video, we're going to be continuing with Three.js by importing a model that we make in Blender. Obviously, pretty important topic. If you're going to be trying to do anything with Three.js, it's very likely that you want to import a model, whether it's one you created yourself or one that you downloaded off the internet. In this case, I'm going to show you how to create it yourself in Blender. We're going to create a super simple model because I am not an artist, but I'll show you if you do work with the modeling software yourself how to do it. And if not, you'll still learn how to do it. We're going to be importing models using a format today called the GLTF format. So if your model is in another format, there are a variety of loaders that work with Three.js. Unfortunately, it would be ridiculously complicated to cover them all in one video. GLTF is the recommended format to use with Three.js, and because we're creating our own model, that's what I'm going to show you how to use today. But hey, I mean, they all work fairly similar, so even if you're importing a model of a different format, maybe stick around, you might learn something. So we're going to get started. So if this is your first time tuning in on the Syntax Byte, this Three.js series I'm going for the checkers, no need to watch the previous video. What we did was we used the orbit controls to add this little checkers board. And what we're going to do today is we're going to add pieces on the checkers board by importing a 3D model from Blender. So to get started, I need to create a basic model. And as I mentioned, I am not an artist. I have minimal Blender experience, but I do know a couple of things. So we're going to create a simple model in Blender that we're going to use as a checkers piece. So to start off, I have the Blender default scene loaded. Now, in Blender, you may wish to render something, in which case you have a camera and you have a light. Because we're going to be importing our model into Three.js, and Three.js is going to be doing the rendering, if you will, we can just delete the camera and the light. I do believe it is possible to import the light along with the model. You probably wouldn't have any use for the camera, but if you wanted to import the light, it should be possible. But to make things simple today, we're going to add our own light in Three.js, and that way we can make sure it's positioned exactly as we want, because if we use the light here, we would probably just end up duplicating the light for every checkers piece, and that isn't what we want. So I have a cube. A checkers piece, it really looks better as a cylinder, so I'm going to delete the cube. I'm going to go ahead and add in a mesh. We're going to add a cylinder. Now you will note that the cylinder, obviously it's not perfectly round. It's made up of some sort of sides. You can add smoothing depending on how many meshes you're adding in your application. You may wish to increase the vertex count here. I forget how to do it in Blender to smooth that out a little bit, because we will be able to see these sides just like I'm seeing now in Blender in Three.js too. So just keep that in mind. I don't know how much it bugs you. It does depend on like how close you are to the object and what the lighting situation is, but just keep that in mind. So to begin here, I'm going to start by scaling, and I'm going to scale along the z-axis, and I'm going to scale my thing down a little bit to be the size of my checkers piece. Now you will note here I scaled the entire object. I did not scale the sides of the object. I simply took my cylinder and I scaled it. Nothing wrong with that, but you'll also notice here that scale X, Y, and Z are no longer all 1. One of them is 0.37. So be aware, because when we import something in Three.js, if we then reset the scale to 1, our object is going to look off. So just be aware of that. And we'll speak more about that later. So I'm going to go back into Blender now and select none. Okay, great. Figured out how to select none. Very proud. We're going to use the face mode. I'm going to select the top and the bottom face. We're going to go ahead and do an extrude with E. We're going to hit enter. We're going to go ahead and do a scale and scale those down. Okay, oops. So one thing is, if you wanted to scale, like you could scale them only on the X and Z axis, or you can just scale them, scale them kind of like this, including on the vertical. And what that does is that puts like a little indent in our checkers piece. So I think that looks super cool for a piece, but I kind of figured this out by accident. Yeah, but there's our checkers piece. So we can go back into object mode. I haven't screwed anything up yet, so let's just stop editing it. It looks like a checkers piece. It's beautiful. Look at that. It's got like some, it's just awesome. So there's a little checkers piece. You will notice that I didn't add any materials. That's okay. We're going to add materials later in Three.js anyway. Obviously, we want to have black and white checkers pieces, so it's okay to just add our materials in Three.js, but I believe this will initially just show up as black, so you may want to add a material here, and that would import with the model. So the big question is, I'm done working on my model in Blender. How do I get it into Three.js? That's the big question here. So you go to File, you go to Export, and you go to GLTF 2.0. You will notice there are two file extensions associated. They are not the same. GLTF is an extension that is non-binary. I believe it stores it in, like, you can open up the file and look at it. It's something like JSON or something like that. GLB is binary. I don't know exactly what the advantages are, but what I do know is that whichever one you choose will work with Three.js. So pick one. Just make sure that when you try and import into Three.js, you use the right extension. Okay? I'm going to choose binary. So here's my game folder. I'm going to go ahead and call this checker.glb, and we'll export GLTF 2.0. And it's done, I think. Cool. So we'll leave Blender running just in case. Ooh. Didn't even realize we could do that. Okay, that's so cool. Just zooming. I knew we could zoom, but I didn't realize holding middle mouse button would zoom in our app. That's what you get when you use controls that you didn't create. Okay. So now we have our mesh created. How do we import it into Three.js? So just like with the orbit controls, the loaders are another thing that doesn't directly come with Three.js. It's not part of this thing because you have to import it separately. So we import it from the same place. GLTF loader it's called, and we're importing from basically the same URL. So I'm going to go ahead and copy this and then just modify it. So we'll go like this, we'll go like that. But rather than being in controls, it's still under JSM, it's under loaders, and then it's GLTF loader.js. Perfect. And so that's the GLTF loader. So now we can go ahead in our init function here, and after we create the board, why don't we add the model? Would make sense. So we can do const loader is equal to new GLTF loader. Then what we do is we do loader.load, and then this is where I'm saying, so I'm going to do .. because I'm in my JavaScript folder here and my checker is outside of it, right? So I need to go up one folder and then to my checker.glb. So just be careful if you saved it, checker. If you saved it as a GLTF, you just need to make sure that you put GLTF there. So just don't go on autopilot and put GLB. And then be confused when it says that it can't find your model. Then we have a callback function for when that is done. It passes GLTF. And what do we do in our callback function? In our callback function, we would like to add our model into the scene. So the easiest way to do this is GLTF has a scene, and you just go scene.add, and you do gltf.scene. Okay, that will add everything in. So like I was talking about before, if you have a light, if you have multiple models in your scene, that will add in the scene, okay? So what we should be able to do now is we should be able to just refresh. And we can see that our scene is in the application. So there's a couple things you'll notice. Number one, our scene is, well, it's a little bit oversized for what we need. It doesn't quite fit on one of our checkers squares, so our checkers piece is too big. Number two, you will notice that our scene is black. Why is it black? Well, there's a couple reasons why it's black. Number one might be that we didn't add any materials. I'm not actually sure if it has like a default material, but another important reason to keep in mind when you're importing 3D models is that in Three.js, there are basically like two types of materials. There's more types of materials, but there's something important to keep in mind here. Our checkers board, we used a material called Mesh Basic Material. What is Mesh Basic Material? What Mesh Basic Material is a basic material that doesn't respond to light. Therefore, even though I don't have any lights in my scene, I can see my Mesh Basic Material perfectly fine. The downside of Mesh Basic Material is that when I add lights to my scene, it won't reflect them at all. Now, because I'm creating a checkers game and I always want the board to be very visible to players, I'm okay that it doesn't participate in the light simulation in Three.js. And it's probably faster if it doesn't. But if you wanted your checkers board to respond to light, to show reflections, then you would have to use a different material called the Mesh Standard Material. And there's a variety of other materials, but the basic one is Mesh Standard Material that will make it respond to light. If I change this to a Mesh Standard Material, though, because we have no light in our scene, then it won't... What's the word I'm looking for? It'll be black. So there's a couple ways we could solve this little problem with our mesh. One would be to add a Mesh Basic Material. I have done that, and it doesn't look good. And the reason that it doesn't look good is that because there's no light, there's no shadows, it's very difficult to see the depth. Again, another thing that doesn't matter for our board, it's just squares, right? Like there's no depth. But because we added that little cut in, it's basically impossible to see that little cut in unless we have a material that responds to light. And our scene can look kind of fake if there's no light simulation at all, which may or may not bother you. It depends on what you're doing. So the other way is simply to add a light. There's a few different ways you can do this. There's some different lights. You can look them up on Three.js and play around with them. The way I'm going to do it is instead of adding an ambient light, which is more like a sunlight, I am going to add in a light that is a point light, and it's going to sit above our board. So what we can do is we can say const light is equal to new 3.pointLight. We're gonna have it emit white light. White light, true white light's probably kind of fake, but that's okay. This, I believe, is the intensity of the light, and then this is the distance of the light that the light will travel. We're going to set the light's position to be in sort of the middle of our board. We're going to set the Y to be something like 10, so it sits, you know, a good ways above the board. Okay. And then we're going to go scene.addLight. So we can refresh and see if that does anything for our poor little thing here. So it does. There's a default material. And so we can see that it is black, or it's gray. So now it looks more like it did when it was in Blender. And you can see that we can see the depth. So that's pretty cool, right? We can see the depth on that piece there. Awesome. So things are looking a lot better now that we've added a light into the scene, but we still have a couple of problems. Number one, this checker is way too big for our board. And number two, we probably want it to be white, and then we want to have white and black checkers. So first off, we're going to deal with the issue of having the checker be too big. So what we're going to do is we are going to actually find the checker in the scene. So right now we're adding the whole scene, which like isn't a huge deal because all our scene has in it is our checker, is our cylinder, which we should have named better. You know, actually I'm gonna do that right now. We'll name this as checker and re-export it because I'll show you this can help us actually find it in the scene. So cool. So right now we're adding the whole scene. We probably want to make sure we're adding just the checker, but what we actually want to do is we want to get that mesh. We want to duplicate it several times for the board, so we just want to find it. So what I can do is I can do const checker mesh is equal to gltf.scene.children.find. So children, we have a scene. The scene has children. The children is an array, so we can use the find. We get child, and it imports the names from Blender, which is super cool. So we can see if the name is equal to checker, and then we'll know it's our mesh. Awesome. Next up is the scale. So we do checker mesh.scale. I think this checker is about a little more than double the size that I want the checker to be. So I can scale it. Now this is where that point I made earlier comes in. Remember how our cylinder here, if I actually knew how to use Blender, that'd be cool. Okay, remember how it's not all 1. This one is 0.3. So if I go here and I set scale 0.5, 0.5, 0.5, our mesh is going to look messed up. Why is it going to look messed up? Because I'm increasing the scale on the y-axis, because the scale was not 1. The scale was 0.3, and then I'm decreasing the scale on this axis. Not a good scenario. What I want to do instead is actually just multiply the current scale. So if I do scale.x times 0.4 is actually what I had in my notes, so we'll go with that. Checker mesh.scale.y times 0.4 and checker mesh .scale.z times 0.4. So now the proportions of our mesh will remain the same and we'll get what we're expecting to get. You can always do this just to make sure it's okay. Like if the scale was 1, you know, say it's a mesh you downloaded from the internet. You don't know if the scale is going to be 1 or not. If you just do it like this, it guarantees that you won't have any problems. If you scale it and it looks off, try this and it might help eliminate your problem. So the next thing that we can do is we can set the checker mesh .position.y to be plus equals checker mesh .scale.y, and so that will prop it up so it's upside the board, and then we can do scene.add checker mesh. Okay, and so we can see what that looks like. Did not appear to work. Checker mesh.scale is not a function because it's checker mesh.scale.set. My apologies to everyone on that one. Okay, cool. So now I have my checker piece. It is above board, so that's nice. Yep, it's sitting above the board. It looks pretty good. It looks about as big as we would expect it to be. It looks awesome. So the last thing that we need to do is to A, put them on the squares where we would expect checker pieces to start, and B, we need to put the appropriate material on the checker piece. So how do we do that? Well, I'm going to create a function. Okay, it's going to be called add checkers. And it is going to take a checker mesh. Okay. One more thing. We are going to add a library to run our checkers or our droughts. I think please tell me this isn't drafts or drafts. I think it's droughts. I don't know. I'm not from the UK, but this is how they say checkers in the UK. So I think it's droughts. The reason I have to use the word droughts here is because there's a library called droughts.js that we're going to use to run our checkers. Because as I mentioned in the last video, this video series is about Three.js, not checkers. Obviously, we have to add a little bit of game logic, but I don't want to reinvent the wheel here. So this will basically, just tell us if a move is possible, give us a starting board, etc., etc. So we don't have to worry so much about it. So droughts.js, we're going to add this library in. I've already added it in my index here, so we don't need to import it at the top of our JavaScript. We can just do droughts is equal to new droughts. And then we can do console.log droughts.fen to make sure it works. So this is a checkers notation thing. It's actually a chess notation that seems to have somehow been adapted for checkers. So we see this string of text here. This is the library working. So it's set up a board for us, which is super cool. The other thing we need to do is when we add our checkers, we need to be able to line up the square number that droughts gives us to a actual position in the 3D space. There's a couple different ways to do this. The way I've decided to do this is by adding onto the user data of each cube the cube number that it is. So we only care about the dark squared cubes. That's where everyone plays checkers, I guess, or the light squared cubes. So you can play on like either color, it doesn't matter. But it seemed to be more common when I was looking this up to play on the dark squares. So given that, what we want to do is when we're creating the squares, we want to actually put on the user data of the square a cube number, and then to find the position, we can search through the squares and find the one that has that cube number and then ask what the position of it is. Obviously, another way to approach this would just be to calculate the position where we would have put the square based on the cube number. That one actually probably is quicker on a runtime basis, but is a little bit harder to figure out, a little bit more code. There's some math involved and we're likely to make an error. So if we just do this, we won't make an error. So what we can do here is I'm going to add a thing and it's going to be called let square number equals 1. Because the squares start at 1, not 0. Every time we do a dark square, we want to increase the square number as well as add the user data. So here we're doing a dark square if this is not true. So we'll copy it, we'll add in a not equal, and then if that's the case, we'll do cube.userdata.square number equals square number. Square number plus plus. Here we'll do the same thing, but because it's a different row, we actually are doing a dark square when this is true. So we'll do that, and there we go. Now we can create ourselves a little helper function called find position for square. So if I go here, function position for square, and I'll give it a square number, we will say const found equals board.children.find where child has child.userdata.cube number equal to the square we're looking for. If found, then we return found.position. This will return a Y position as well. That's totally fine. We're free to ignore it if we don't want to use it. I don't believe we're ever going to use it, but it's just a little bit cleaner just to return the whole position. Because if we return a vector 2, then it's X and Y, but really we want X and Z. So this is the cleanest way I found to do it. And then otherwise we just return null. So now what we can do is we can run through the entirety of the board. So there's 50 squares that are used in the checkers game, but there's 100 squares on the board because it's a 10 by 10 board. So we'll do for let I equal to 0, I is less than 51. Remember, because we're going up to 50, I plus plus. Then what we will do is we will say let piece on equal droughts dot get I. So this is going to give us black, white, or nothing. Okay. So if piece on is equal to black, which is represented by a B, then we will do And what we can do is we'll also do const piece equals checker mesh.clone true, so it's a deep clone. So we're gonna clone that mesh. Then what we'll do is we'll say if piece is black, we'll do piece dot material is equal to a new mesh standard material, because we're going to respond to light, and we will have that be a color which is going to be not quite black. So what I found is that if we make it totally black, it's very difficult to see the little inset in the piece, the detail in the piece. So I'll just make it 222 So close to black, you can make it 111 you know, a very dark gray, but not quite black, will help us see the detail in the piece. Else if piece on is equal to white, then we do piece.material is equal to new mesh standard material. This one I had totally white too, but we might actually try a similar thing, because I had the same issue where it doesn't show really the detail of the mesh. So we'll try and do something like E, which is like an almost white, but it's just a little bit not quite there, and that might help add a little bit of detail into the piece as well. So now what we can do is we can do piece.userData.color is equal to black. This might help us out later when we do ray tracing, which is our next video, and we'll do the current square is equal to I, just because, you know, might be helpful to be able to utilize that data. Not really doing anything for us in this video, so you can skip it if you want to. And then we do a scene.add piece and a scene.add piece. Actually, no. So we have to set the position first. So we go piece.position.set, and then that is going to be square position, which we didn't get. So we'll go const square position is equal to position for square I. Okay. And then we'll do, oh, I spelled square position wrong. Bear with me, guys. Square position dot x, we'll say piece dot position dot y, because we don't want to move it back down into the square. And then we'll do square position dot z, and we can just basically copy this line for the next one. Cool. You could, you know, supposedly put these two lines outside of the if statements, or you could bring a couple of these lines into the if statements. The big thing is you want to make sure that if you're not in either one of these if statements, that you don't accidentally end up adding a piece to a square where there isn't supposed to be a piece, right? Because this piece on thing, it might not be black, it might not be white, it might be a blank square. There might be nothing there. So in that case, we don't want to add anything in. Okay. So the next thing to do is call our add checkers function from our callback in the loader, which is somewhere. So instead of scene.add checker mesh, we're going to do add checkers checker mesh. And the best thing to do is refresh and hope for the best. So it doesn't show us checkers, and that's okay. Checker mesh is not defined. Well, that's a bit bizarre. On what line? GLTF loader 154. Oh, add checkers 85. Checker mesh is not defined. Because I said check mesh, and so it should be checker mesh. So try it again. board is not defined. Yes, so an error here, I didn't have board as a global. I still let it remain as a local variable. Apologies for the errors, guys. Mesh standard material is not defined, because it should be 3.mesh standard material. If you guys think you make a lot of errors when you're programming, like square position is null. Here I say cube number, but here I say square number. And we have our pieces. See, you just work through your errors like that, and there you go. So yeah, you can see kind of like what I was saying with the white pieces is that it's hard to see that little inset in the piece. It's like, it's possible, but it's kind of tough to see it. You'll also notice that the sides of the pieces are like fairly dim, which for the black pieces doesn't seem like a big deal. For the white pieces seems like a bit more of a big deal. So you could add additional lights. You could try adding an ambient light and see if you like the way that looks better. You know, it's only certain angles of the board that it really matters, but you could add lights towards the side. You could add a directional light coming in kind of from here. The world is really your oyster, but at least we can see our little pieces. So that is going to be it for this video, guys. We have the pieces on the board. The next thing is really to allow us to select a piece with the mouse and move it to a position, and that is going to be done using ray tracing. So stay tuned for the next video. I hope this video was helpful. I do apologize, there were quite a few errors in that most recent bit of code, but I hope you stuck with me to figure out those errors. And if you're, new to programming and feeling discouraged, I mean, hey, hopefully I showed you, just calmly work through the errors, have a look at the line. Chances are you just spelled something wrong. In one spot you used a variable, then you mistook and thought you named it something else later. Really, it just ended up being spelling mistakes, forgot to add that 3 on the mesh standard material, just a namespace issue. So again, I do apologize. I do try and prepare for these videos, prepare good notes, but also sometimes I'm improvising a little bit on camera to try and make things even better for you, even better than I'd prepared, and sometimes I fall when that happens, and I'm pretty sure that's what happened today. So nonetheless, guys, I hope you enjoyed the video. Do throw a like on the video if you enjoyed it. Subscribe to the channel. I love to receive your comments. Really helps keep me motivated to continue making these videos. And I will see you next time for ray tracing. Bye-bye.